Next is integral of greatest integer x square dx goes to 0 to 3. First interval will go 0 to 1. Because we have x square here and the limit is 0 to 3. x square है इसलिए हम next limit लेंगे 1 to square root of 2. Square root of 2 is 1.414 because we have square here. So we take the square root values whose value lies between 0 to 3. Square root of 3 is 1.732. So last one is 0 to 1 plus 1 to square root of 2, square root of 2 to 3 and square root of 3 to 2. Now greatest integer x square when the limit is 0 to 1 is 0. In this case 1. Square root of 2 square is 2 and square root of 3 square is 3. Integral of 1 2x plus 3x. Put the limits root 2 minus 1. 2 root 3 minus 2 root 2 plus 3 into 2 6 minus 3 root 3. 2 root 3 minus 3 root 3 minus 2 and plus 1 and 6 minus 1 is 5. 5 minus root 2 minus root 3. Next is integral of greatest integer x square. Limit goes to 0 to 1.5. 0 to 1.5. So first interval 0 to 1. Then 1 to square root of 2. Square root of 2 is 1.414. And next one is square root of 2 to 1.5. 0 square is 0, 1 dx and 2 dx. Integral of 1 is x. Integral of 2 is 2x. Square root of 2 minus 1, 2 into 1.5, 3 minus 2 root 2. 2 minus root 2. Next is integral of greatest integer 3x dx. Limit goes to 1 to 2. When x belongs to 1 to 2, then 3x belongs to 3 to 6. Greatest integer 3x dx. First limit goes to 1 to 4 by 3. 5 by 3 to 6 by 3, that is 2. Three by 3 is 1. Because we have here the greatest integer 3x, so multiply the limits by 3. 3 by 3 is 1. हमें 1 से लेके 2 तक हमारी लिमिट्स जाएंगी. So first limit will go from 1 to 4 by 3, 4 by 3 to 5 by 3, and 5 by 3 to 6 by 3. 3 into 1, 3. 4 by 3 into 3 is 4, and 5 by 3 into 3 is 5. Integral of 1 is x, 4x, 4 by 3 to 5 by 3, plus 5x, 5 by 3 to 6 by 3. 3 into 4 by 3 minus 3 into 1 plus 4 into 5 by 3 minus 4 into 4 by 3 plus 5 into 6 by 3 minus 5 into 5 by 3. Four minus 3 is 1. 5 into 4, 20, minus 4 into 4, 16, 5 into 6, 30, minus 25, 12 by 3, 4. Next one is when function is x minus greatest integer x and greatest integer x is integral part of x, then find the integral for minus 1 to 1. First limit will go from minus 1 to 0 plus 0 to 1 greatest integer of minus 1 is 1. So x minus 1 dx, x minus 0. X minus plus 1 because we have minus 1 here. Now solve the integral. Integral of x, x square by 2 plus x square by 2, 0 to 1. Upper limit is 0, minus 1 square, 1 by 2 plus 1 by 2. Half plus half is equals to 1. is equals to a to b f of a plus b minus x dx. हमने इससे पहले तीन प्रॉपर्टीज करी थी. The next property is this: when the function is continuous on the interval a to b, then integral of a to b fx dx is equals to integral of a to b f of a plus b minus x. अब इस प्रॉपर्टी के रिलेटेड क्वेश्चन करेंगे. Integral of square root of x upon square root of 3 minus x plus square root of x, and the limit goes to 1 to 2. We will apply this property here. A plus b, 1 plus 2 is 3. So 3 minus x, 3 minus x plus 3 minus x. Square root of 3 minus x, square root of x plus square root of 3 minus x. Let it be equation 1 and this be as 2. Now add 1 and 2. Add left hand side in the left hand side, I plus I. In the right hand side, limits are same and the denominator is also same. So just add the terms. 1. Integral of 1 is x dx. Integral of 1 is x. And the limit is 1 to 2. So I is 1 by 2. Pi by 6 to pi by 3, 1 upon 1 plus square root of cot of x dx. We can write cot as cos upon sine. Take the LCM in the next step. Square root of sin x plus square root of cos of x. Limit is pi by 6 to pi by 3. Function is continuous in this interval pi by 6 to pi by 3. So pi by 6 plus pi by 3 minus x. 3 pi by 6, that is pi by 2 minus x. So the function, instead of x, we write the value as pi by 2 minus x. Square root of sine pi by 2 minus x plus cos pi by 2 minus x. What is the value for sine 90 minus theta? Sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. So write the values here. Sine 90 minus theta is cos and cos 90 minus is sine. Again add first and second equation. Pi by 6 to pi by 3. Square root of LCM is same, denominator is same. So after taking the LCM, just add the terms which are in numerator. Integral of 1 is x. So I is pi by 12. dx upon f of x plus f of a plus b minus x is equals to b minus a upon 2. Since the function is continuous, so we will apply the fourth property here. F of a plus b minus x, a plus b minus x plus f of a plus b instead of x, a plus b minus x. Integral a to b f of a plus b minus x let it be 1 and this equation has 1 and 2. Add 1 and 2. Denominator is same. Just add the terms which are in numerator. Integral of 1 is x so I is b minus a upon 2. This is what we want to prove. Next property is integral 0 to a f of x dx. If the function is continuous in the limits 0 to a, then its value changes to f of a minus x. Again the same property, a plus b minus x वाली, सिर्फ इसमें हमारे पास जो a लिमिट है वो 0 हो गई है और b लिमिट्स की जगह पे a आ गया है. इस प्रॉपर्टी को यूज करके हम क्वेश्चन करेंगे नेक्स्ट. Zero to pi by 2 integral of sin x upon sin x plus cos of x. Use this property, sin pi by 2 minus x, sin pi by 2 minus x plus cos pi by 2 minus x. Sin 90 minus theta is cos. So integral of cos x upon and cos 90 minus theta is sin. Let it be 1 and this equation as second. Denominator are same. Add 1 and 2. By adding we get 2i. Denominator is same, sin x plus cos x. Just add the left hand side, sin x plus cos of x. Integral of 1 is x, upper limit minus lower limit. 2i is pi by 2 and I is pi by 4. Next question is same as it is. Instead of sin x, we have the value square root of sin x upon square root of sin x plus square root of cos x dx, and limit is also same, 0 to pi by 2. Instead of sin x, we have the term square root of sin x upon square root of sin x plus square root of cos x.